In today's video, we're going to look at the LU factorization of a matrix and how we can use this factorization to solve a square system of linear equations. So a square system of linear equations is simply a system in which you have the same number of equations as you have unknowns. So at the heart of the most efficient and modern algorithms for solving linear systems is the LU factorization, in which the square matrix A is expressed as a product L times U, where L is a lower triangular matrix and U is an upper triangular matrix. And so we say that if the n by n matrix A can be written as the product of a lower triangular matrix L and an upper triangular matrix U, then A equals L times U is an LU factorization of A. As an example, we're going to find an LU factorization of this matrix here. And this is also going to be used to introduce the technique for finding the two matrices. So what we do is first start with the matrix A. We will now perform elementary operations on this matrix to put into upper triangular. Specifically, there's only one elementary operation that we wish to focus on, and that is type 3. We absolutely cannot interchange two rows in this process. Well, upper triangular, remember, means that every entry below the main diagonal, which in this case, our main diagonal is right there, is 0. So what we have to do is we have to zero out this 2 and this negative 10. Start with this 2, right? So we're going to do negative 2, row 1, plus row 2. I'm sorry, plus row 3. Right? The result of that operation right? Again, I'm going to highlight the main diagonal. Now what's left is to zero out this negative 4. Right? And that can be done as 4 row 2 plus row 3. That is now upper triangular, so we take that matrix as our matrix U. Notice that we're not necessarily putting it into REF, right? To put into REF, we have to make this 14. We have to make this 14 here a 1. We don't care about that. We just want it to be upper triangular. Now, to determine the lower triangular, what we do is we set up a matrix in which we have 1s along the main diagonal. And remember, to be lower triangular, everything above it has to be 0. That only leaves, for this example, these 3 entries that we have to determine. And they can be found directly from how we found our upper. Right? Notice, to zero out that 3-2 entry, We multiplied by a 4. So we're going to make that entry -4. So 3, 2 is -4. To zero out that 1, 3 entry, we used -2. So the 1, 3 entry in our L will be +2. And there was nothing to zero out in the 2, 1 entry. So that is a 0. Right, so here's our matrix U, here's our matrix L. Right, another way you can look at finding L is you take a look at each step as you're zeroing out. Notice that the 1, 3 entry here was 2, right? And that was the 1, 3 entry in L. The 2, 1 entry was 0. That was our 2, 1 entry in L. And then once we did that, we had to move on to zeroing out the 2, 3. Notice that the 2, 3 entry was -4, and that's our 2, 3 entry in L. Now we can use the LU factorization to solve a system. Right, so once we have obtained an LU factorization for A, we can then solve the system AX equals B very efficiently in 2 simple steps. First, write Y equals UX and solve LY equals B for Y. Then we solve UX equals Y for X. Okay. So if we look at this system, wish to solve it, first thing we should do is obviously write the coefficient matrix only. We get 1, -3, 0, 0, 1, 3, 2, -10, 2. I'm also going to write down somewhere my B vector. Right, -5, -1, -20. Right, because that will be important. Well, you should notice that this matrix is the same matrix from example 1, right? So we already know what the LU factorization here is. Right, so here's our matrix L. Here's our matrix U. And this is all from example 1, right? The next step is we wish to solve Ly equals B. Right, so L, 1, 0, 0, 0, 1, 0, 2, -4, 1, times our Y vector, Y1, Y2, Y3, is equal to our B vector, which was -5, -120. Right, so this will give us a system of 3 equations. Right, so interpreting it, first equation will be y1 is equal to -5. Then we have y2 is equal to -1. Then 2y1 minus 4y2 plus y3 is equal to -20. Now this is a nice example in the sense that it gave us both a value for y1 and for y2 immediately. Normally, what will happen is, based on the fact that this is a lower triangular, is it will give us the y1 value straight away. Then we substitute that into the second equation to find y2, and we substitute both of those into the third equation to find y3. Right, but here, we already know y1, y2, so just plug them both into equation 3. We get 2 times negative 5 minus 4 times negative 1 plus y3 has to equal negative 20. Right, we get negative 10 plus 4, which is negative 6, plus y3 is negative 20. And so therefore y3 is negative 14. So our y vector is the vector negative 5, negative 1, negative 14. Now we set up the equation ux equals y and solve for the x vector. Right, so u was 1, negative 3, 0, 0, 1, 3, 0, 0, 14, times our x vector, x1, x2, x3, equals our y vector, negative 5, negative 1, negative 14. Right, set up the system. x1 minus 3x2 is equal to negative 5. x2 plus 3x3 is equal to negative 1. And 14x3 is equal to negative 14. Now, in this case, since we have upper triangular matrix, we will always be able to solve immediately for x3. Then we do backward substitution, plug that into equation 2 to find x2. Right? Then plug both x3 and x2 into equation 1 to find x1. Right, so solving this part up here, right, the Ly equals b is essentially forward substitutions. Solving for ux equals y will be backward substitutions. Well, right away, we can tell that x3 is negative 1. Right, so that means that x2 plus 3 times negative 1, which is going to give us x2 minus 3, has to equal negative 1. And so we get x2 is 2. Which means that x1 minus 3 times 2, which is x1 minus 6, has to equal negative 5. And so x1 is positive 1. Right, and so our solution to the system is 1, 2, negative 1. And that concludes this video on the LU factorization of a matrix. So again, remember that you can only find the LU factorization of a square matrix. So only square matrices have an LU factorization. And not every matrix, not every square matrix can be factored as a product of a lower triangular and an upper triangular. Which means that not every square system is going to be able to be solved using the LU factorization. In the next video in the series, we are going to start looking at the determinant of a matrix. And so in the next video, we're going to define what a determinant is, as well as develop a technique for finding the determinant of a 2x2 matrix and a 3x3 matrix. As always, thank you for watching. I hope you enjoyed, and I will see you all in the next video.